Hello and welcome to TGIK. I am 2 minutes late today. I accidentally locked myself out in the hallway again. So I was just standing out in the hallway like TGIK is about to start, but I don't have a key to get back in. Luckily, one of my very nice colleagues let me back in. Anyway, happy Friday, everyone. It is good to see everyone. Let's see what's going on in the chat. Oh my gosh, so many people chatting already. Okay, so this week's HackMD is first. Good to see you, Heptio. I think George is out today, so I think we have Duffy on the line. If not, I can also drop stuff in the chat as well. So I'll kind of be playing the role of both myself and of George/Duffy today. Okay, very first one we have is Seth Miles. I finally get to see one live. Howdy from Bryan, Texas. Bryan, Texas, I feel like I've been there before. I used to live in Texas. Anyway, good to see you, Seth. Lamatti, one of my favorite folks to join. Happy Friday, everyone. Nova for president. I would be a terrible president. I might be like better like general or something, but I can't make decisions. Suresh says, hey. We have Gustavo, hello from Chicago. Martin, hello from the Netherlands. Antoine, hi from Paris. Christoph, hello from Dusseldorf, Germany. Crazy. Memo, hello, happy Friday from Virginia. Mozufer, hi from Dubai. Let's see, wow, a lot of people here today. Herman, hi from the internet. We had good evening from Sweden, good evening from Rotterdam. Hello from Finland. Learn Tech to Innovate says hello Nova, ... Geert, hi from Belgium. Hi from New York City. So that's funny, hi. That's how you say like hi, like a friendly hi in Icelandic. Like if you're like walking up to, the gas station or whatever, you just be like hi. And anyway, that's just cool that you typed that. Okay, let's see what else. Tim, hello from Germany. Peishu, hello there. Lynn, hello from North Carolina. I'm assuming NC. Hello from Belgrade, Plano, Texas. One of my best friends lives in Plano, Texas. Hi from Brazil. Hi from Ukraine. I think that's the first time we've seen Ukraine here. Hello from Johannesburg. Hi from, I thought it said Iceland, but it's Ireland. Hello from Ireland. Hello from New York City, and hello from Bangladesh and Denmark. And it looks like more and more people are jumping into the chat. Anyway, hey everyone. Happy Friday. Welcome to TGIK. We're going to be talking about, it's pronounced, I actually talked to one of the authors, it's pronounced KEDA. I might call it KEDA, but we'll see how it goes. And we are here live in the Heptio studios, and this is kind of sad. So today is our last day here at the Seattle office. So everybody from Heptio is out here in the hall. We're about to have kind of like a going away, saying goodbye to the office party. So after this episode of TGIK, I get to tear all of this stuff down, load it up into my Subaru, and we're gonna hang on to it until we get our new office over in Bellevue. So this will be the last TGIK in this room, and it's really sad. And so what I think I'm gonna do is, after this is done, I'm gonna like stand back and like do like a 3D panorama so y'all can see exactly how horrible this desk is. It's covered in like M&Ms and like pencils and like Diet Coke cans. It's really great. So anyway, that's a bit of sad news, but we're getting bigger and better, so it's also exciting at the same time. Okay, so earlier somebody dropped in the HackMD. It's the very first link. It's here, I'll drop it in again. You can click on that, and that's what we're gonna be pulling up here in a second. Okay, so I just put that back in the chat. Let's go back to my screen. Let's actually go and open this thing up. Bam. And let's drag it up here. There we go. So this week, like I said, we're doing exploring KEDA. I'm going to really try hard to get this right because I've been calling it KEDA in my head all week. Exploring KEDA with Rabbitmq and Go. And we have some stuff to talk about. And we're going to try to make this week a little bit fun. But I think I'm kind of on my own here, so we'll see how much fun we can have and how we can orchestrate a lot of this. Anyway, the first thing that we wanted to do was This Week in Kubernetes. So I went and found some stuff that I think is exciting, and I hope you like it too. 1 second, pulling up the chat. Christian says floor M&Ms are the best. We don't have floor M&Ms, but like I bought this, and I'm pretty sure I'm the only one who ate M&Ms out of this over like the past 6 months. So those are the M&Ms that I've been munching on here. They've just been sitting in the TGIK room for forever. And I used to have like some stuffed gophers and stuff in here too, but I took all them home. Anyway, the first thing we have is this really exciting blog post, or not blog post, but like this guy, I'm assuming it's a guy. Somebody put this up on Reddit, and they're giving away a few of the Cloud Native Rejects tickets to give away for free. So regardless of if they're still available or not, thank you so much for doing this. This is great. I wanted to point this out because I know a lot of folks will get invited to conferences, or they'll have like an extra bed in their hotel room, or they'll get an Airbnb or something. But there are a lot of people out there who will take advantage of this, and it can be a really big game changer for them. So if you ever are in an opportunity where you can help someone out, you'd be surprised how many people are actually interested in stuff like this. So thank you so much for doing this. And then also, that's going to tee us off for this conference in general. So we've seen this a few other times in the industry, but this is the first time we're doing it the cloud native way, and this is right around KubeCon. So the idea here is if you submitted a talk for KubeCon and for whatever reason you didn't get accepted or you couldn't make it, you could also submit that same talk here, and we're putting together sort of like the KubeCon talks that didn't make it post-conference. That's unofficial. So if you're going to be in Barcelona for KubeCon, I'd say also come and check this out. A lot of these talks are going to be really great. There's one of our folks here at VMware, Jason. He works on Cluster API. I know Carolyn from Microsoft. She's amazing. Rita from Microsoft, also amazing. So there's a lot of good talks here. And honestly, these are the talks that I feel like folks really put their heart and soul into, so that you'll actually probably take away quite a bit more from this conference than you would from KubeCon, in my opinion, anyway. People really, really like to give talks, and if they're that passionate about it, you can bet that they worked pretty hard on it. Okay, so that's Cloud Native Rejects. So here's where you can go and talk to Lawrence about the tickets, and here is the link to Cloud Native Rejects. Okay, so Sadaz says, can we make an episode about HPAs with custom metrics? Please, please, please. I'm pretty sure that's today's episode, honestly. We're going to be talking about HPAs, and the way that KEDA works is it has custom metric server that it plugs into it, and it does all that through a CRD. But we'll look at all that here in a little bit. But yeah, if we don't touch on it today, we can certainly touch on it later. But yeah, once we get into the KEDA part of the episode, we can talk more about that. Okay, so next we have visualizing YAML. So this is exciting. So I came across this, and the first thing I saw was, how do you visualize dependencies in Kubernetes YAML? And then I asked myself that question. I was like, Nova, how do you think of YAML? And I literally just think of a notebook of YAML, and then I don't really imagine the relationships or how it fits together spatially. I'm not a very spatially minded person. I'm a Unix programmer. Who would have thought? Norman says hi from London. Hi, Norman. Good to see you. So anyway, I was like, okay, let's see what's going on here. This might be a cool color coding or something for YAML to make it easy for us. And the first thing I did is I just kind of started scrolling, and then I was like, oh, whoa, there's a ton of really cool graphy, relationship-y things going on. So then I went back to the top and actually went through and read this. But yeah, it's just talking about some different tools. There isn't any static tool analysis YAML files, but you can visualize dependencies in your cluster with WeaveScope, KubeView, or Istio. Holden says his smiley face. I'm pretty sure Holden is trying to say hi. Anyway, hi Holden. It's nice that you're on my stream and I'm not hanging out on yours. Ashish says, hello Chris, hashtag supernova. Ashish, another one, waves. Hi, good to see everyone. So yeah, anyway, if you want to have awesome fancy graphs for your YAML, you can use any of these three tools here. And if you want to see what they look like, you can come through and you can say, okay, option one, here's WeaveScope, and here's this really cool GIF. And it's a project from our friends at GCP. Hats off to our GCP friends. And you can come in and you can sort of explore your Kubernetes cluster. So, I think it was last year, I wrote this tool called Krex. Here it is here. It stands for Kubernetes Resource Explorer. And, there's a... That's funny. Okay, so if you come in here, you can see that we have all of these different Explorer implementations, and it allows you to walk through your Kubernetes cluster based on label matching. So you could come in and you could say, okay, I have a pod with this label, and then I want to find the deployment that's associated with that, and then I want to find the service that's associated with that, and then I want to find the namespace that's associated with all the things. And Krex kind of lets you do it and bakes in some convenience tools and stuff. You can spin up a debug container and whatnot. So this was kind of a prototype. I never finished it, and it's not don't run this, it's not good. But this idea has been a problem for a lot of folks for a long time, which is how do I actually start to visualize and navigate my Kubernetes cluster? How do all these different resources, which are inherently relational, come together, and how do I start thinking about them as a human? So here we have some tools that kind of help us with this. So this first one is Weave Scope. This other one looks really exciting because I just like the colors, and it's like simplified, but it's called Cube View, and you can actually go in and you can see like the different YAML and see how things are mapped together and explore your resources this way. And last but not least, we have good old Istio here. That's showing us how our traffic is working. And so this is more like of a network topology. And I've seen some libraries like this in JavaScript that can help you build these interesting maps, and I think you can drag them around. But yeah, if folks are interested in these, we could probably do like a visualization episode where we kind of like look at all three of them. There's Linker D2, there's Kubrix, and there's Jaeger. And then there's probably even some more that we can find if we really start digging into it. But yeah, people are starting to finally visualize how Kubernetes is working and how everything is coming together, and I think that's really exciting. Okay, let's close this. Next, this one's exciting, K3s. So the sort of joke here, everybody knows K8s. Some people say Kates. Here, let me do this. Doc cam. Oh, y'all aren't supposed to see these yet. We're going to talk about these later. You didn't see those. So with Kates, if we take the word Kubernetes, and we count 1, 2, 3, 4, 5, 6, 7, 8, we replace those 8 characters with the number 8, and that's where Kates came from. And this is just smaller and is a little bit more Twitter-friendly than this. And so this is like our 3-letter Kates. And then you note there's observability, which I'm going to kind of abbreviate here, observe, and then ... ability, right? That's where the word Ollie comes from, which is there's an 11 in the middle because there's going to be 11 characters that spell out the word observability. So K3s is a joke on this first one that says it's like Kates, but 5 times smaller. So that's where K3s comes into play. Pokemon Kates, yeah? So yeah, let's see here. Let's go back to my screen. So, and of course, the very first thing we see at the top of the K3s page is it's lightweight Kubernetes. It's a smaller version of Kubernetes. And we see this analogy based on like the Linux kernel, right? And Linux distributions. So we all know there's Alpine Linux, there's Linux from scratch. Knoppix is a really great lightweight Linux. There's Puppy Linux. There's a ton of like intentionally designed small lightweight Linux distributions out there because there is a market for this. And for the first time, we are seeing a distribution of Kubernetes that is also small and lightweight for folks who want to run Kubernetes on small devices. Like maybe you want to run it on a Raspberry Pi, or you want to do some like micro instances or something. This might be something that you would be interested in running. Usually lightweight implies simpler, and in some cases can imply more or less stable. But yeah, you see here it's great for IoT, great for ARM, great for CI. IoT is the Internet of Things, so like if you wanted to put your espresso machine on the internet, ARM is the processor that doesn't really get super duper hot that we have in all of our smartphones. CI, custom integration, that's how you, continuous integration, that's how you get your containers built. Waleed says one podcast calls K3s as keys. I don't know how I feel about that. I kind of like K3s. I don't know. I'm not in a naming mood. Okay. So anyway, this is K3s. I think I'm going to do TGI Cam this next week. I really want to do it. But let me know what folks think, and if anybody's tried it or can point me to any resources. This is a new project. It just came out. You can come to GitHub, and you can see it's from our friends over at Rancher. And here's the GitHub repo, and you can see it's already got 6,000 stars, so this is exciting that this was released. So come check this out if this is your thing. So that's K3s. Okay, CFP for North America. So if you go to Twitter, well, here's my Twitter account, everyone. If you go to Twitter, you can see the CNCF tweeted, San Diego, here we come, the CFP for Cloud Native, and then you can click on the link here, and it'll take you to the actual CFP page for KubeCon North America. So the way KubeCon works is there's 2 KubeCons every year. There's one in EU. Well, there's 3 now. There's one in EU, there's one in China, and there's one in North America. The one in North America changes its location. The one in EU changes its location. I don't know about China, but we try to space them out. Like 2 years ago, it was in Seattle, and then last year it was in Austin, and then this year it's in San Diego. I think I did that right. Wow, I can't believe I've been going to these for 3 years. Anyway, if you want to submit a proposal, go here. I'm happy to help and take a look at this. I think this is going to be the first KubeCon I don't submit any CFPs to, just so I can just kind of enjoy KubeCon for once and not be stressed out the entire time. But yeah, I'm willing to take a look, help people out. If not, we can connect you with other folks. If you're interested in submitting a CFP, we can always do everything we can as a community to get you what you need and increase your chances of getting accepted. Looks like we have some people in chat. There's also K3Os. What is K3Os? Let's show this. The Kubernetes operating system. What is this now? Rancher Labs. K3Os is an operating system completely managed by Kubernetes. It launches in seconds. Okay, so this is also cool. It's K3OS. Get started with K3OS. So I think it's an operating system built on top of K3. So this is really cool as well. See, I really want to do K3 and K3OS. Purpose-built OS for Kubernetes, fully managed by Kubernetes. This is awesome. I really want to play with this stuff. So yeah. K3, K3OS, thanks Rancher. Exciting new technology that we're going to take a look at hopefully next week. So there's that. We've brought this up once before, but I'll mention it again for shameless self-promotion. Joe and I are going to be at KubeCon in Barcelona, so if you're going to be there, come say hi. Joe and I we put together, and we were working on this earlier this week, so we actually are getting pretty excited about this talk. It's going to be exciting. We're doing what the past 2 years of TGIK has been like, and what are the lessons we learned, and how did we get to where we are today. And we have some exciting announcements for what's to come in the future. So if you're going to be around, you're a TGIK fan, you want to get some TGIK swag, come hang out with me and Joe. It's going to be a super relaxed talk, very similar to TGIK, and you'll get to see, I think this will be the first time Joe and I have been together on stage, so you'll get to see our exciting energy in person. So yeah, come check us out. And speaking of KubeCon, and this is the moment we've all been waiting for, let's go back to our dock camera. Speaking of KubeCon, and I already mentioned this was our last day at the Seattle office. So I think 3 years ago, it was when I was at Microsoft, it was before I even worked here, I printed off a few thousand Charmander Kubernetes stickers. And I'm cleaning out my desk, and in the very back of my desk, I found a brand new package that I had forgotten about of unofficial Kubernetes Charmander stickers. These are exciting because everyone knows Pokemon Go runs on Kubernetes. It was one of the first big production workloads. And so we're big fans here. And I think the history is there's a Pikachu one and a Bulbasaur one as well. And I think the original one came from Tim Hawken over at Google. He did Pikachu. Anyway, I like Charmander. He's one of my favorite Pokemon. So if you're going to be at KubeCon, you can come get one from me. So I'll give every person I meet one, and it's first come, first serve. So you got to find me at KubeCon. Also, today we're going to do trivia, and we're going to give away 10 to one lucky winner, and we'll mail it out to you along with some other Heptio, VMware, TGIK goodies. Okay, so the question is, the first person, so the way this is going to go is I'm going to ask a trivia question. The first person to get it right in the chat is going to be the one who gets the stickers. Okay. What is the date? What is the date of my first commit to Kubernetes Cops? Ready, go. We're gonna see who wins. I don't even know when this is. So I'm gonna look it up too. So let's go over here. Kubernetes Cops. Now, how do we do this in GitHub? There's a way to do it. I think you go to 545 contributors. Yeah. Kris Nova, here I am. No, I don't want this. I want my Kubernetes Cops. 150 commits. Older. Keep going. So I think the answer is Alan 1/1/2017. Let's see if Alan gets it right. Oh my gosh, how many older commits are there? Here's one from October 21st, 2016. October 15th, 2016. This is the end. This is my first commit right here. Removing work in process line from the README. Yep, so my first commit to Kubernetes was literally a one-liner. And let's see who got this right. It looks like, let's see. I think Ben Moss is our winner, right? Hold on, I want to make sure I get this right in the chat. Let's see. Who sees the screen share and types fastest? So 10:15. Blah, blah, blah. Okay, yeah, I think Ben Moss did it too. And you know what? For good times, let's do another one that's not going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's 10 for Ben. And let's do another one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There. Okay. The question is, I'm going to put it in the chat so that everybody sees it at the exact same time. The question is, the trivia question is, I want it to be Kubernetes related. No, let's do this. How many, or I'll type it. All right, there you go. So whoever gets that one right, I'll send 10 stickers to you as well. And then the rest of them I will bring with me to KubeCon. And congratulations to our friend Ben Moss, who got the first one right. So Sidaz, Charmeleon, and Charizard. Correct. Okay, so Sidaz is our next winner. Very good, Sidaz. Okay, cool. So let me write this down so I don't forget. And what I want y'all to do is either on Twitter or Kubernetes Slack or any, my email's out there on my GitHub, my work email. You can message me somehow. Track me down, however you want to track me down, and shoot me over a good mailing address with your name, and I will make sure that we get this stuff out to you. So we have Ben gets these, and Sadaz, how did we spell that? S-A-D-A, and then a bunch of Z's. Okay, cool. Charmeleon, Charizard, Fire, Flying. Ooh, Holden got both their names and their types, but I think Holden already has Pokemon stickers, so that's okay. Waleed says we did not see the question. Okay, we might have to do another one. Let me see, maybe I can order up some more stickers. Come on, I'm a Bulbasaur person. Okay, we're getting off in the weeds here. Let's go back and let's jump back in our doc here. Okay, so anyway, that's KubeCon, and those are the stickers. Congratulations to Ben and Sadaz. And everyone else, thanks for playing. We'll try to do some more trivia in the future, and I'll try to come up with a way to make it fair for everyone. Like maybe I can drop a link or something, and it'll count down. I don't know. Open to ideas here, if anybody has any good ones. Okay, so last but not least, let's have a good transition here into KEDA. So this is the blog. If you want to learn about KEDA, come here and read this. This is going to be everything I'm going to say today is written in here, and a lot more is going to be written in here as well. So this talks about everything from what is it doing, why are we auto-scaling, it has some really fancy graphs, and it comes down here and you can see this is how the whole system interacts, how everything works. We're going to be talking about all this in detail, so I'm going kind of fast right now. But what I really wanted to get to is this thing here, the scaled object. So this is a Kubernetes CRD. And what a CRD is it's literally anything you want. You invent these from thin air. You can put whatever fields you want in here. So for instance, if we pull this up, let me see if I can zoom in. There. So you can see here we have kind, we have name, we have spec, we have conversion, groups, we have names, we have more versions. All of these things were just typed by a person, and they could be anything you want. You could have a CRD that represents Pokemon. You could have a CRD that represents a server. You could have a CRD that represents your best friend. It doesn't really matter. It's literally like a schema for a database. That's how I think about CRDs. And then a CR, this is actually an example of a CR, is one instance of a CRD. So a row in a database, right? And you can have multiple rows. So you could have a database of favorite animals, and row 17 is a dog, and row 18 is a cat. And those are various CRs. So you could have different types of your CRs, of your CRDs called CRs, custom resources. So how does this different or complement Knative? I think this is, it deals with a lot of the same problems Knative does, and I think it's just kind of a simpler implementation of it. And I think when I was talking earlier, I was talking with Jeff over at Microsoft, and one of the things he really hammered home was how Microsoft and Red Hat plan on growing this with the community. So I think that's going to be one of the big differences between Knative. Okay, so anyway, scaled objects are kind of like the core of how this whole thing works. And I guess just to kind of like talk about what KEDA is, let's just go ahead and let's just pull up the repo and let's start digging into this thing. GitHub.com. Actually, let's go here. I'm just going to Google it. KEDA Kubernetes. GitHub. Okay, so github.com/KEDA-core/KEDA. So we all know my favorite thing to do here is read the first line and see if I can tell what this thing is and what it does from the first line in the repo. So KEDA is a Kubernetes event-driven auto-scaling component. It provides event-driven scale for any container running in Kubernetes. So my understanding of this, and if folks are on the phone who have worked on KEDA, please, please, please jump in and correct me. Keep me honest here. My understanding is KEDA takes some of the lessons learned from serverless functions that our friends at Microsoft had built up in Azure and applies them to Kubernetes. So when we say it's an event-driven auto-scaling component, what we mean is there's an event, some sort of event will happen, and there's a lot of different open source software that like have hooks that you can like trigger events with, which is a fancy way of saying like it'll send an HTTP request somewhere, or it will like drop a socket or open a socket, or it will touch a file in a directory. There's a lot of things you could do and have your software do that. Then you could take that and plug that in to a different system, and you could have a loop that says, oh, I'm watching this file system. I'm watching this file system. There's nothing there. There's nothing there. Oh, there's a file. That's an event. Jeff says, thanks, Kris, that's perfect. So arbitrary events that we can then plug in to Kubernetes autoscaling. So let's talk about, we know what an event is, let's talk about what autoscaling is. So some folks at home have heard the term HPA, which is it's another acronym. I'm not a super big fan of acronyms. I very much prefer verbosity whenever I can. So HPA stands for Horizontal Pod Autoscaler. So that's actually a project in Kubernetes, Horizontal Pod Autoscaler. And we want to find the GitHub. Where is the GitHub? Okay, so this is like the spec and how it works. But if you look in here, there's an auto-scaling algorithm, and then there's a way where you can plug into it using the HPA object. So let's just see. Next steps, overview. Okay, I'll just read this out loud really quick. Overview. The resource usage of a serving application usually varies over time. Sometimes the demand for application rises, and sometimes it drops. In Kubernetes version 1.0, a user can manually set the number of serving pods. Our aim is to provide a mechanism for the automatic adjustment of the number of pods based on, in this example, based on CPU utilization stats. But in our KEDA example here, we're not actually reading the CPU. Instead of using the CPU to auto-scale our pods, we're taking these arbitrary events and we're plugging them into the horizontal pod auto-scaler. So I'm gonna go through this hypothetical situation, and this actually happened to me at my first job in my career. We were an online e-commerce store, and I was writing an API for the store. So Learn Technology says, Waleed, KEDA native still spins on Kate's HPA, which is reactive. KEDA is event-driven autoscaler. So KEDA also uses HPA, which is what we're learning about right now. So anyway, what happened in my first job is we were a dropshipping company, we were an e-commerce company, and every year on Cyber Monday, our site would go down because so much traffic would come in. And this was back in the days of load balancers were just kind of the new hotness. And so we were exploring with different types of load balancers. I think the ELBs in AWS had just come out. Waleed says, thank you. So anyway, what happened was all the traffic on Cyber Monday would hit our website and effectively would DOS our site. Well, it would be a distributed DOS, a DDoS, because it was coming from all over the internet. And there were so many users that our servers couldn't keep up and our site would go down and our server would quit responding and in some cases break. So what the horizontal pod autoscaler would do in that scenario is it would say, oh my gosh, CPU is going crazy. We obviously need more resources here. So we would spin up more pods and distribute the traffic evenly across those pods in the hopes that our CPU is going to go down in exchange for our amount of pods going up. So you're sort of doing this exchange of amount of instances of your app for happier CPU, right? And that's how the horizontal pod autoscaler works. So in this case, what we're doing is we're taking these arbitrary events and we're doing the same thing. As an arbitrary event happens and goes up, hopefully our autoscaler also goes up. So this is a direct relationship instead of an indirect relationship. And we're going to try to demonstrate that today with Rabbitmq and Go. And we're going to have some work that I'm pretty sure Jeff Holland over at Microsoft, who helped me out earlier today, thank you so much, Jeff, that he's been working on. And we're going to look at the code, see what's going on here, run some tests, talk about KEDA, and then talk about maybe some other examples of how you would want to use this moving forward. So let's dig into the code. Actually, how do we want to do this? I think we dig into the KEDA code and get an understanding of what's actually going on here. And then I think we go and we actually run the end-to-end and watch it live, I think is what we want to do. Hold on one second. Somebody just messaged me. Oh, it's Ben and Seda messaged me their addresses in Kubernetes Slack. I was like, I hope everything is okay. Usually when I get a Slack during TGIK, it means something is wrong. So learn tech, innovate to innovate says code, code, code. Honestly, that's my approach. I love starting at the main function. That's my favorite way to do anything. Hold on one second. I'm going to grab some almond milk. Okay, so let's do that. Let's look at the code. And in fact, why don't we just open this up in my IDE? So here we have TGIK, but we want to go, actually, let's go to my terminal first. Change directory to my Go path, source, github.com, list, and we should be able to clone this. Bad credentials. So let's refresh our credentials. Kris Nova, my password, and my two-factor auth. Where's my phone? Auth. And let's see here. So this is going to be Merle and Merle. Okay, cool. So this is going to check out KEDA in our Go path for us. So then we should be able to come here. Main.go and command click. That's how I started on Sonaboy. Awesome. So let's come here. Let's do file open. Let's go to Nova, Go, source, github.com, KEDA. Open this up. See what we get. New window. Go root is detected, and let's go here. Okay, can everybody see this? Is the size good? Is everybody happy? So I'm gonna guess our main, right here in the CMD directory. So for folks at home, we're looking at Go. If you don't write Go every day, you probably don't understand what's going on here, so I'll try to kind of boil it down. There's some common parlance in the Go programming community. The CMD directory is commonly where the entry point to your Go program is going to be, and that's where you will define all your commands and subcommands. The PKG is the guts of your programs. These are all of your libraries that this main file is probably going to interact with. And then we have tests and images and some examples and stuff, and those are pretty self-explanatory. And then we can thank Kubernetes for this, but there's this lovely thing called hack, which this is where all of your hacky shell scripts and all that noise goes. And then I'm assuming there's going to be a makefile somewhere in here. Yeah, here's our makefile here. So if you want to actually come through and see how they're building everything, we have publish edge chart, we have build chart edge, we have build, and this just puts together your build for you. So we'll actually probably do a make build here in a bit. We can do a make test, we could do a make E2E test, whatever. Okay. And then here we can use Goose and Gorch to define AMD64 in Linux. So you could actually come in and do AMD64 FreeBSD and this would compile for the FreeBSD kernel. So the Go programming language is pretty slick because you can just define whatever you want there. And again, that's called Goose and Gorch. So the environmental variables, Goose and Gorch. Go OS and Go architecture, but Goose and Gorch, obviously. Okay, so let's go to our main.go. And actually, let's just see if this thing will even build. So change directory into KEDA, core, change directory into KEDA, and let's do a make build and see what happens. So cgo enabled equals 0, goose equals lineage, gorch equals AMD64, go build. We do an LD flag. So this is just populating in our main package the variable get commit with our commit hash here. So this is probably how we're baking our commit into. Let me close some stuff. My computer's heating up here. Baking our commit into the program. Ah, my computer is going crazy. Hopefully, I'm not losing folks on this stream here. Here, I'm just going to type. Let me know if my computer starts lagging. My compiler, or my fans are going nuts during this compile. Okay, cool. So yeah, that actually worked, it looks like. So let's see where it went. So here, do we have like an output file maybe? Let's look at our main file and see what this thing does. So make file. Wow, that was really cool. That just worked out of the box. I'm very impressed there. Oh, so it goes, this -o means the output is dist KEDA, or KEDA. Seems fine so far. Okay, thanks for letting me know, Ben. So I bet if we go into dist here, change directory into dist, yeah, we can execute this. Cannot execute binary file because it's compiled for Linux. So if we wanted to come here, Elisiano says, sorry, I can't hear you. Just kidding. Thanks, Elisiano. You know, if we wanted to move this to a Linux machine, we could execute it, or another workaround here would be to go up here. We still want AMD64, and then we just change this to Darwin because I'm running on my MacBook. And I bet if we go up and we do another make build, we'll be able to execute that one. So everybody's saying my computer's good, so we're going to let this compile. I'm not going to worry about lag. And let's go and start looking at the source code why this is building. Okay, so main.go. What's going on in here? Yeah, so here's that git commit var that I just explained with our LD flags. So this will actually get populated whenever we build our program and effectively get hard-coded every time you run the program. So that's how you get the git commit hash. And I bet yeah, right here, somewhere in the program, we're just going to echo this out, the Kata version in the git commit down here. So that's how that works. So let's see. Main function, we do print version, which is this little function down here. And that just does just logs some stuff, pretty easy. We init logs. I'm assuming this just sort of instantiates our logger. We defer logs, flush logs. This all looks fine. Then we call Kubernetes get clients. What is this now? This is in the Kubernetes package. And then in my IDE, I can hit this target up here. And you can see, so this is kind of confusing. It's called the Kubernetes package, but it's the Kubernetes package within the Kata program world. So they wrote their own package called Kubernetes, and they have their own client Go, and it looks like this is just a wrapper for getting your various Kubernetes clients that you need. One from client set, which this is the Kubernetes native package, and then we have this other one, new for config, that we call kube client here. So okay, so we get some clients, and the clients are going to basically be how we interact with Kubernetes and with Kata. We grab some context. We initiate a new scale handler. So I'm assuming the scale handler is the thing that actually will handle interacting with the HPA and getting all of that nice and happy for us. And then we in a concurrent Go call, we do controller, new controller, and then we do run with our context. Okay, so this line is like the guts of the program here. And we run it concurrently, which is interesting. And then it says, okay, so it's running. If adapter, new adapter, run. It does this other run thing, which we can go in and dig and see what this run function does. Oh, and this is just an if statement, so it's unable to run the custom metrics adapter. okay, so this is what is going to build the custom metrics adapter that's going to talk to the HPA. And then instead of actually waiting on this go line here, usually you'll see like a go, and then like we'll have like a channel that you'll hang on, and when the go routine is done, it'll like send a true or a false over the channel, and that'll break our code. Here it looks like we just do a sleep effectively for 5 seconds, and then we terminate our program blind. So I would not want to see this in production code in real life, just because in theory this could still be executing and we shut down our program prematurely. So you could do something like you could come in here and you could do let's see, make, we'll call it ch-chan. And it'll be, actually, I don't need to go into it. But basically, you would make a channel here, pass it into this function here, and then here you would just basically do this, and whenever this, and then in this function, you would just have it return something across your channel, and then your code would move forward. And there's some examples of that we can talk about later. I don't want to get too off in the weeds here. So yeah, so basically the high-level pattern here, let's draw a quick picture so we can see what the program is doing, is chan bool. Yeah, thanks. So here, Ashish is helping me out here. Chan bool, so this is what we want. And then we would pass this in to run. So maybe we would change our function to accept a channel here. And then, down here we would do effectively that. And then somewhere in our code, we would have a line that takes the channel and goes like this. Bam. And so until this line is executed in the previous function, this will hang. And that's how we could do concurrency there. And Go makes that unbelievably easy for us. We don't need a mutex. We don't need anything at all. So thank you, Go. And then, yeah, there's Ashish quit true. Yeah. So thanks for helping me out, Ashish. But that's how we would do it. And, yeah, so let's draw a picture. And let's high-level this thing for everyone. Let's go to our dot camera here. Get rid of Ben and Sadaz here. Here's our Pokemon friend. And if we're looking at our main function, so the first thing we do here is we get 2 clients. We're going to call one for KEDA, and we'll call this one C for client Go. So we get 2 clients. Then we go down further in the code path, and we do a new handler. So I'm going to kind of draw a circle for functions, and these are variables. So we have a handler, and then we have an adapter. And what the handler does is it's called a scale handler. So we're going to do scale handler. And then the adapter, refreshing the concurrency module I did on Tour of Go. Nice. The scale handler, and then here we have the adapter. And so what the adapter does is this is going to basically run the custom metrics adapter. And this is going to handle generating our CRD. So if I had to guess, I would say the scale handler is going to be what is going to create. And Jeff, I want you to answer this for me if you're still here. I think the scale handler is what is going to create. Wait for it. This scaled object. So again, I think this is going to come from this part of our code here. And then the adapter is just what plugs this that we've already created into the HPA, so the HPA will go and do all of its magic and scale our pods for us. Now, what you need to understand here is there's 2 layers of stuff going on. So let's say this bottom half of our page here is a Kubernetes cluster, right? So let's say we have a couple of nodes. So here's node number 1, here's node number 2, and here's node number 3. And these are let's just say they're all T2 larges running in EC2, right? Some fairly large machine, couple of cores, maybe a few gigs of RAM, no big deal. Nothing to freak out about. And let's say that right now we had 3 instances of our application. What Kubernetes would do is it would run one instance here in a container. It would run the second one here in a container, and it would run the third one here in a container. And then we would load balance our traffic across all three of these using some load balancing algorithm like round robin, and it would just go around in a circle and say, oh, next request goes here, next request goes here, next request goes here, next request goes here. Or it might, there's other algorithms that are smarter than that, and we can do a whole episode on load balancing later. But anyway, the point I'm trying to make right now is if we created a fourth instance of our application, which is what the HPA, the horizontal pod autoscaler, would do, is it would change the amount of replicas we want, and it would scale that up and down. If we created a fourth one, Kubernetes picks a server. So let's say Kubernetes picks this server, and there's a whole algorithm into play that goes on to how this decision is made. And we honestly should probably just do a TGIK on that algorithm alone, because that's some fascinating software right there. So this is our fourth one, and then let's say our fifth one goes here. So who can guess where the sixth one's going to go? It's going to go here. So the point I'm trying to make is Kubernetes does its best it can to distribute your load evenly. Now the problem comes in is if you said I wanted to do my replicas and I wanted to set that to like 1 million, Kubernetes would continue to deploy containers on each one of these nodes, but at some point, this is a finite amount of system resources. At some point, we're gonna cap out all of these servers here. So in a weird way, Cluster API is to servers as the horizontal pod autoscaler is to pods. And so what the Cluster API would do is it would say, okay, we've set replica equal to 1 million. We obviously need some more servers here. And then Kubernetes would go and start distributing across all of these servers until we were able to meet this replica count here. So pods are the layer of software on finite resources, and nodes are the layer of hardware that runs those resources. So we got to make sure we have a clear understanding of that, because we're going to go into the pod autoscaler bit a lot in a second. So anyway, this is Kubernetes. By default, Kubernetes gives you this layer of handling, and we're working on getting this one solved in SIG cluster lifecycle today. Okay, so that was my little rant there. Let's go back, not to my face, to my screen. And it does that by interacting with the CRD here that we call a scaled object. So let's go back to our code, and let's validate that our assumptions are correct. So new scale object, we said this should actually create our CRD. And then all this does is it returns a handler, so we can go back here. And then we do this run command here. And let's go here. And here we say run, we call run. And I bet if we come in here, scaled object informer, bam. There's our CRD right there. So yeah, our assumption was correct. So this will go through and it'll create the controller and create the CRD that we need, and it calls this run function down here. And you can see it calls this scaled object informer, and it calls run, and it passes in our context. And here's exactly that pattern that we were looking at earlier. You can see that we're actually just doing this with context in a concurrent Go function here. So Arathi says, hello, one of the devs on KEDA. Oh, hi, Arathi. Please jump in and keep me honest and make sure I'm explaining all this correctly at any point. If I mess up or use the wrong word or something, we want to make sure we're giving accurate information here. So feel free to jump in and correct me. Everybody at home is going to appreciate it, including myself. Okay, so this creates our scaled object, CR, and then we have this adapter. Let's go into this run function here. And here we have a stop channel, which is a similar concept to the concurrent pattern we looked at earlier, but this will actually just stop the function. And then we have a generic API server, prepare run, and run. And let's see what this run does. Run spawns the secure HTTP server. It only returns the stop channel if closed, or the secure port cannot listen on initially. So this is actually going to run the server bit for us here. Okay, cool. And that's how basically KEDA works, is it gets these two components, the scale handler and the adapter, and those two things go and make everything work for us behind the scenes. And so we're going to glue all this together in Kubernetes as we run this. So far, I'm going to pause here and stop for questions and grab a sip of my Diet Coke and allow our friend Arathi, I hope I'm pronouncing that correctly, a moment to chime in if there's any commentary they want to make before we move forward with our example here. So questions or commentary coming at you now, and if not, we're going to move forward. So let's see here. We want to go. We'll get this ready. Arathi says, hello, and again, thank you for joining us. We very much appreciate it. Okay, so it doesn't look like anybody has any questions or commentary. If you do, feel free to jump in. And I'm going to go ahead and get started. So what we have here, let's actually go and do this. Cloud.console.google.com. Is it console? It's console.cloud, isn't it? Yeah, okay. I always get that wrong. So here in Google, we went and I just spun up the world's simplest Kubernetes cluster. It's a 3-node cluster, US Central 1A, and it's called TGI 076. We come down here, back in our terminal. Oh, let's see if we can execute this now. Perfect. Okay, so it doesn't run. So we were able to compile it. Okay, so if we come down here, we all know I alias k is equal to kubectl, and I can do a kget nodes. And we can validate that we are in fact talking to our GKE cluster here. GKE TGIK 076 default node pool, version 1.11, and all of our nodes look nice and happy and have been up for a few hours. Okay, so with that being said, you can gain, one of the first commands I like to run when I walk up to a Kubernetes cluster, I usually run my alias kdump, which is basically this. Kdump is equal to kubectl get all -- all namespaces. And that doesn't get everything, but it gets most things, enough to where you can start to understand what's going on in your cluster. Oh, so Arathi does have a comment. Okay, you got it right. The main components are controllers, and this listens on CRD, create an update. In the handler, it handles activation, deactivation, and HPA and scalars in the adapter. Okay, so all Arathi is basically saying there is he's just confirming this diagram that we looked at a little bit earlier with the scale handler in the adapter as well. And he says creates, updates, and deletes. And that when he says create, updates, and deletes, he means this is basically got CRUD on our CRD that is a scaled object. I know my handwriting's messy. That's how you know I'm a good engineer. Okay, so there's that. Let's go back to my screen. And so now we can just run kdump, but even more appropriate than kdump. If you really are just walking up to a Kubernetes cluster and you just want to get an idea of what in the heck is going on in this cluster, kget namespaces. What namespaces do you have? And here you can see we have Kata, which is terminating. This does not look good. Probably the finalizer issue that we ran into last week. Ashish says, I think you are pronouncing her name incorrectly. How can somebody help me pronounce it correctly? March 2009 CRM1. I think you are pronouncing her name incorrectly. Okay, so yeah, if somebody wants to kind of do the phonetic spelling, I'll try to correct that. Thank you. And we might run into some problems with Kata here. In fact, k delete namespace Kata. Okay, yeah. So let's do this. We're going to create a fresh cluster. I don't know what was going on with this cluster earlier, and I don't really want to debug it, but we can talk about what's going on, why this thing spins up, and it should spin up pretty quick. Okay, so yeah, we'll just do that. Okay, so back in our terminal here, we're going to start to run our command, and if we get into trouble, by the time we get into trouble, we should have a fresh, brand new cluster with nothing running on it for us to play with. Okay, so here we have the chart, and we scroll down, and we have Rabbitmq and Go. So Ashish says Arathi, no A after R. Arthi. 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 Arthi? Okay. Is it, I want to get this right. Is it Arthi or is it Arthi? Okay, so here we have Rabbitmq consumer and sender. So basically what this example is going to do, I'll just read it to you. A simple Docker container that will receive messages from a Rabbitmq queue and scale via KEDA. The receiver will receive a message at a time per instance and sleep for 1 second to simulate performing work. When adding a massive amount of queue messages, KEDA will drive the container to scale out according to the event source. Remember we talked about events earlier? Last one, Arthi. Okay, Arthi, got it. Arthi. Okay, so all that this is really saying is, and I feel like I should draw another picture, but I'm going to try not to. All this is saying is we have a rabbit queue. We can put some messages in the queue. Let's say we put 10 messages in the queue. And in order for us to do something with that, what we're calling work, or those 10 messages, we have to create 10 containers. Each one will pull the message down from the message broker Rabbit and will sleep for a second and then terminate. And that is simulating like a program that would like be processing a request or something. And so if we threw 1,000 messages in the queue, you can see how exciting we can start to design these systems for some load testing. And again, we have various events that we can plug into KEDA. I'm curious there, and Arthi, maybe you can answer this question for us. But we have a few events. I know Rabbitmq is one, and I think there was talk of Kafka, and I saw some other Azure functions and queues, and Kafka on OpenShift 4 here. But I think each one of these events has to be kind of baked into the program, right? Like, if we wanted to have an event that, say, was triggered from one of the AWS message brokers, or maybe we wanted to use like a Redis global lock or something, we would have to write new software in order for that event to plug into the rest of KEDA, correct? Correct me if I'm wrong there, because it would be cool if there was like a plugin module or something where you could load all that dynamically in the same way we sort of handle various checks on our pods in Kubernetes, like the readiness probes and the health Z endpoint and things like that. But anyway, let's go back here. Rabbitmq. So we're going to start by going through this setup here. It says prerequisites. We need a Kubernetes cluster, which we have one. It may or may not work for us. And then we need to install Kata on it. Yes, that's right. Each of these need a scalar to be written. Okay, so Arthi confirms it. So let's see if we can't find the scalar code while we're here. Scalars. Ah, perfect. Okay, so here's our Rabbitmq Scalar. Okay, cool. It's a plugin system, but it's not dynamic currently. Good feedback. Thank you. Thank you for taking that feedback. That's so amazing. So here, if we look in the Kata repository, remember earlier I mentioned PKG, or package is like the guts where all the libraries are. Here we have a package called Scalars. And in here, you can see we have Rabbitmq, Kafka, the Azure Servers bus, and the Azure queue. And of course, if we go back to the repo, we go back, Rabbitmq, Azure queues, Kafka. It's all here. So we're going to want to look at the Rabbitmq Scalar. And so let's see if we can't kind of understand what's going on here. So I'm assuming there's got to be an interface for this somewhere. I bet that's what's in scalar.go. Gosh. Okay, so really quick, Arthi, your code is gorgeous. I love the way you have this thing set up. This is 100% exactly how I would do it. Good show here with having your scalar interface exactly where I would want to put it. And it just popped up almost like magic when I was like, I wonder if this is it. So anyway, here we have the scalar interface. We have get metrics. We have get metric spec for scaling. We have is active and close. And here in the Rabbitmq Scalar, how much do you want to bet we're going to be able to find? We have a new function, and then I bet we can scroll down, and here's our is active. Here's our get metric spec for scaling, get metrics, and there was probably one more I'm missing. Close. Here it is. So every one of these scalars is going to implement this interface, and it's going to have these functions defined, and all it's going to say is get metrics spec for scaling. That's just going to mean a different thing in the case of Rabbit than it would be for anything else. So we could literally write a scalar today that checks if a file exists, or checks if Twitter is up, or, does virtually anything we want. So Jeff says Rabbitmq, Kafka, Service Bus, AWS SQS scalar is being worked on. Yeah, so folks at home, if you want to use Kata and you want to contribute a scalar, it looks like it's set up and it's going to be pretty easy for you. All you would have to do is come in and add one of these scalar files in a scalar test.go so you can test your scalar. Looks like the Rabbitmq doesn't have a test. Whoever wrote the Rabbitmq should write tests. Shaking my finger at them. Anyway, so that's how the scalars work. And this allows us to map arbitrary things very conveniently to the rest of our KEDA system, which again is going to talk to our horizontal pod autoscaler here. So really all KEDA is doing is just gluing together some sort of arbitrary action or thing with the horizontal pod autoscaler, and it's just defining like a rigid structure to make that interaction as seamless as possible. Okay, so those are scalars in KEDA. So let's go here. Actually, let's just check and see what's going on here. Okay, so this is already up, so let's connect here. Boop. And I'm just going to nuke my kube config. Kube config. And we'll just grab this really quick. Kget nodes. I don't know why the internet's going slow today. There's our brand new cluster that we just spun up a few moments ago. Okay, cool. So let's go back to KEDA. We now have a brand new cluster with nothing installed on it that I haven't broken yet. And the finalizers for the namespace are nice and happy, and the namespace has never even been created, so we should be good there. So the first thing we want to do is install KEDA. So we have this bit done, Kubernetes Cluster, and now we want to install KEDA on the cluster. And then, of course, deploying with a Helm chart. So in order to install KEDA, it looks like, I mean, in theory, I have a binary right here. I could just like kubectl run this thing if I had it in a container. But what the folks over at KEDA have done is they have used a tool called Helm, which basically is an abstraction on top of YAML and allows you to template YAML and then define like variables and a little bit of logic for your Kubernetes resources. And we can glue all those together, and we call that a release. And then a release is an idea that's important to humans. So in this case, our important idea is KEDA. And we're going to use a tool called Helm to add that. So let's see what we got going on here. And yeah, I used to work at Deas with all the Helm folks way, way long ago. They're now at Microsoft, and honestly, some of my best friends in the world. In fact, one of the folks from that team is how I got in touch with Jeff, and it was just like a trip down memory lane. It was just really great getting to talk to an old friend again. Okay, so anyway, let's see. Jeff has a question here. It says, Ashish, good question. We do have a release out, but you're right. We need to shore up the system to sync with GitHub releases. And Learn Tech to Innovate says, Jeff Arthi, how does KEDA different from the custom metrics in HPA? Okay, so I'll let those two answer that question, and we're going to go back to Helm here. So I've already done this, but we'll do it again for good measure. So the way Helm works is you need a Helm repo. So Helm was originally designed to sort of be like apt-get for Kubernetes. And the same way with most package managers, you can add arbitrary repositories. And all a repository is just an HTTP, I think, S server that is just set up in a special way that Helm knows how to go and look for various things that the server can give it. And if the server is set up correctly, then Helm will treat that as a valid repository. So we're going to add a new reference, and all of that information is stored somewhat invasively, but here in the Helm directory on my computer, you can see here we have repository, and in here we have local cache repositories.yaml, and if we, of course, cat out repositories.yaml, you can see here we have all of like Kubernetes charts. We have my repository, we have Jenkins X, we have KEDA core that I've already added. And let's go back to our Go path. And that's how Helm sort of stores all this meta information about it. KEDA. Okay, cool. So we're going to do our Helm repo add command. Which is here. Helm repo add, KEDA core has been added, although it was already there. And then we do a Helm repo update, which this is one of those things about Helm that you just got to kind of learn to get used to doing. And this will just like pull updates from each of these repositories and stash them locally in that directory we just looked at. And then here's our install command here. So before we do this, you may be asking yourself, where is this coming from? What am I about to install? Where is it coming from? Where can I run it? What's going on here? And this is one of the things that, like, granted, Helm makes things a lot more convenient, but it also kind of blinds you from what's actually going on. But you run into the same issue with any package manager. Like, if you're on your system and you do an apt-get update, you're blindly downloading packages from somebody on the internet who just said, yeah, these are pretty good. You should run these. but you don't really know what's going on there. So anyway, if we wanted to find out where this was, we can go to this server here, or what this was, more importantly. Oop. And it's an XML server. And I think there's like, you have to like send a post request, or like Helm has some weird protocol that I don't know off the top of my head. But regardless, there's going to be a chart hosted on this server somewhere, and Helm's going to be able to recognize that. And all a chart is if we go back to, let me close some of this stuff. If we go back to the repo for KEDA, let's close that, and let's go back to our KEDA repo. Where's GitHub? We'll just type it in here. There we go. This is what I want. We go back here. You can see we have this chart/KEDA, and this is actually a representation of what we're running. So the way that Helm works is here in the templates directory, these are all Kubernetes resources. So if you've ever seen a Kubernetes deployment before, this deployment.yaml will look familiar. If you've ever seen a Kubernetes service before, this service.yaml will look familiar. And if you go up a directory, this is where you define the template-y, abstraction-y bits that Helm likes to use in this file here called values.yaml. And the way that this works is Helm will take this YAML file and plug it into these YAML files using this templating thing called text template. And you get this lovely jumble of YAML and text templating. That's really hard to read. And in order for you to actually understand what's being deployed, you have to go and look up KEDA full name is going to get set to name here in our deployment. And so I go up 2 directories. I go into values.yaml. I look for the KEDA object, which is not here. I don't see it. Name override, full name override. Maybe it's here. Where is this thing at? I bet maybe you pass it in when you do your install. Let's see if that's the case. KEDA installed, so we're back here again. Yeah, namespace KEDA, okay, and then name is KEDA. So yeah, you just pass in these various things here whenever you do your install. Okay, so we could come through and we could go back to our GitHub page here. Let's do KEDA core. And we could actually see what all of our is being set up here. So we do a cluster role binding, and I'm going to kind of go fast here, but I've worked with Helm a lot in the past when I was working on that team, so I can read this stuff pretty well. And I'm just going to try to explain what we're about to install on our cluster. So a cluster role binding, this will probably be the 20th time I've said this. It's like a bridge table in a relational database. It maps a user or a person or an idea to some access level that says you can get on this resource, but you can list on that resource, but you can't get on that resource. So sure, you can get pods, sure, you can get services, but no, you can't get deployments, or whatever the case is. And all a cluster role binding is just the glue that sort of matches those two together. I think of like the old like operators in like the phone booth, like patching in all the patch cables and connecting people. That's a cluster role binding. Okay, so all that's doing is it's setting up our RBAC for us in the KEDA namespace, which is good. We want to see RBAC. That's happy. We have a custom API service. So this is an API service. And basically, we have version priority, priority group minimum, insecure skip TLS verify. So this has got to be some sort of a custom, it's a custom metrics thing here. So we're probably using that to define some service level configuration. We have a deployment, which this is not too terribly long, but you can see here, what I really care about is the values image repository and values image tag. So if you come up here to templates, to KEDA and go into values.yaml, this is values, and then we have image, KEDA core, and tag is latest. So that's actually defining where we're pulling this container for this deployment. And I'm assuming all that this is, if we go look at our makefile, that's where we're going to connect everything together from our main function that we just looked at all the way to this Helm command here. So that's the glue. So anyway, I ran this, so we're happy, but there you can go and you can look through everything and see how everything works and check it out if you want to. And now we're going to do our Helm install. And of course, if we go back and we look at KEDA, you can see there's a handful of other things. I've already gone through and kind of scoped these out. And we're getting close on time, so I want to kind of hurry up along here. But we do define a service. We have a service account, which this is the person in the RBAC example. And then we have our scaled object, CRD, which remember the scaled object is the unique schema for this specific project. And we define all of that, and then we do our Helm install, and that command is running here. And what we'll see is we'll actually spit out all of the things we did here. Alan Fraser says, Helm debug dry run helps read the rendered template for those of us who struggle to read the raw charts. So yeah, so Alan's just basically saying if you check out the chart locally, you can do Helm debug dry run, and it'll render the template and echo it out for you, so you don't have to do that mental map like I was just doing. So yeah, this is install. Oh, you know what's going on here? I need to install Helm on my server. So I have this lovely bash alias here that will install Helm. And then we can do Helm. So basically the way Helm works, and this is just a pattern that they picked a long time ago, it installs this thing called Tiller in the root namespace of your cluster, and it's a gRPC server. And Tiller is what actually manages all of the things and does all the interaction with your cluster. And Helm is just a thin, lightweight client that interacts with Tiller. And so that's really what's going on here. And kubectl apply without running Tiller. So yeah, so here, so Ashish is just saying you could do a kubectl apply if Tiller isn't running and you'll still get your rendered template. I think the Helm debug dry run is a little bit, makes a little bit more sense for me. Okay, so anyway, so we want to see, well, these are all the Helm commands, first of all. So you can come through and you can figure out all the goodies that you can do with Helm. There's a ton of stuff here. We already did a TGI on Helm. But we can do a Helm ls, and we can see if we have anything running, and of course we don't, so we just get a new line. We also have a deploy folder with a deploy YAML. You can use skipping Helm. Okay, cool. So Arthi says there's a deploy folder here. Okay, I should have done this. So yeah, here's our service controller, and then here's our YAML. Okay, cool. So if you wanted to just come through, and this is all the YAML that we're looking up in the Helm chart. Here's our cluster role binding we talked about. I bet if we look in here, we can find our, yeah, here's our scaled object CRD. I bet our deployment's in here somewhere. Yep, here's our deployment. And you can see here, we Kata core, Kata latest. So yeah, this is a little bit more literal and a little bit easier to read. So if you want to come check out the YAML, come look here. And this and Helm is just building this for us from all of those other YAML files and just glues it all together and gets this. Okay, cool. So anyway, we can run our Helm install command now. Oops, sorry. Let's grab this command back here. Helm install. So we'll paste this in, and we will run it and hope for the best. There it goes. Okay. So here you can see all the files we looked at in the templates directory in the chart, and the values YAML file that we just looked at in the deploy directory all match here. Here's that cluster role binding again. Here's that deployment again. We looked at the service a little bit. Here's our API service we looked at, and there should be a CRD in here somewhere. Custom metrics, where's our CRD? Huh, interesting, maybe it's not in this one. Anyway, let's do our kdump command and actually see what's going on. So kdump is that alias I showed y'all earlier. It's gonna do kubectl get all -- all namespaces. And we can sort of see here, let me zoom out a little bit. We can see here everything that's running in our Kubernetes cluster, mostly. So here we have the namespace Kata, and it's running a pod, and that status is running. Here we have a namespace called Kata Edge, and this is a service. And here you can see we have a Kata deployment and a Kata replica set. So I bet if we do a kget po namespace Kata, yep, sure enough, there is the Kata service. So this is the same program that I just compiled locally. Marcel, earlier I explained a little bit what a CRD is. I'm not sure if you're a MySQL person or not, or a relational database person or not, but a CRD is effectively a schema for an arbitrary idea. So earlier I used some examples it stands for custom resource definition, but I used some examples like it could be like animals, and you could have, what color is it? Does it have scales? Does it have fins? Does it have eyeballs? And you would just define a schema like you would for anything in a relational database. And a CR is just one instance or one row that defines a unique implementation of whatever your schema is. So a CRD just looks like a blob of key value pairs in JSON, right? And if we were doing favorite animals, you could imagine what that would look like. And you can make these things be whatever you want and have whatever types you want, the same way you can with like a relational database schema. Okay, cool. So anyway, let's grab logs on this one. So k logs minus in KEDA, name of our pod, minus f. Okay, and earlier when we ran it locally, let's open up a new tab here. So go back to my Go path, go source, github.com, KEDA list, change directory to deploy. Nope, it was dist. There you go. So if we run this locally, you can see here we get an info and we get log level in our KEDA version, and then it effectively breaks because we don't have some environmental variables defined. We don't want to run this thing locally, but what I want to show you is how this is going to match what we see here. Right there. So you can see this, it's the same software running. So Abdemor says, thinking about CRD like a plugin, design a new YAML definition and a new resource, then implement the controller for it. Marcel says, it's a way to extend the K8s API. That way you can make K8s have custom resources without having to code it into the K8s code base. And then there's looks like Christian added some stuff. So yeah, however you want to think about it, it's literally just an arbitrary idea. And then usually they're used in controller patterns. And I've got some talks on that I can point you to, or if you want to talk to the folks in the chat about it, go for it. But basically, all the CRD does is define what you want, and the controller just loops over and over again and tries to make that happen, doing like an audit and an event loop. Okay, so anyway, I'm off on a tangent. We got KEDA running, we got logs for it. So now let's go here. Let's go back up a directory, and let's see what's next in our tutorial here. KEDA is installed. Good, which means all those scalars that we looked at, all of that logic is now running in Kubernetes in a loop over and over again. So the next step here, we're done installing KEDA. So we've got Kubernetes installed. We installed KEDA on the cluster. Next, we want to clone this repository here. So I'm going to use that clone command I have. Clone, and now we just want to go to this directory here, which is, so basically clone is just smart enough to hit GitHub and say, oh, it's a Go program, I should put it in the Go path. That's all it really does. And you don't need to you can just put GitHub and it's smart. So you can actually do things like clone Kubernetes and it'll go find Kubernetes for you. Anyway, if we go to this directory, go in here, you can see we are now in this repository here on my local computer. And then it said, yeah, of course, just cd into that repository. So now it says we want to install Rabbitmq. So another bit of Helm rant here. If we want to install Rabbitmq, the part of this command that you really need to understand is this part here. So this says stable/Rabbitmq. That's the what. What are we installing? And then we override some, remember that template file? There were some variables in there. We can override that using this --set flag. So we're just setting user and password to whatever we want it to be. We'll just keep it what it is for now because we're just doing a demo. But this part, where is this coming from? So go to github.com. Actually, let's do Helm charts Kubernetes. Helm.sh, here it is. github.com/helm/charts. Here, if you look, we have incubator, we have test, and we have stable. And inside of stable, I bet we can scroll down and let's see, what was stable/Rabbitmq. LMNOPQRS Rabbitmq right there. And then this is just going to be another Helm chart, just like the one we looked at earlier, with a values.yaml, with templates, except for all this is doing is it's just bringing up a regular old Rabbitmq message broker. Now, it's opinionated in the sense that, like, if you want to set up your message broker, like say you want to have highly available Rabbit, this may or may not do that for you because it's going to make a lot of assumptions about how you want to install this. But if you happen to want whatever the folks who work on the charts team prescribe as a good or a smart idea, you can go ahead and you can Helm install this right here. So that's what we're going to do, is we're just going to trust this for the sake of the demo, and we're going to do a Helm install Rabbitmq just to get it running. So let's grab our command again, and we'll copy this and we will install it. So run that. Okay, you can see here, just like last time, we got a list of everything it installed. It installed a service. It installed a stateful set instead of a deployment this time. We got a pod. We even have a secret, that's our username and password. It looks like we have a config map to configure Rabbit, and we even did some RBAC-y things here at the end. So, and then we have like this lovely little output, like how to actually use it, which is pretty handy. So what we want to do now is let's do kgetpo, and this is just in the default namespace, and you can see we have Rabbit running. But if we do kgetpo in the Kata namespace, you can see we have Kata running. So we need both of these running in order for us to do our demo, right? Because we're going to use the Rabbit message queue as the event to do some horizontal pod auto-scaling. So we come in here and let's grab these logs now. K logs -f. And we can see that this is all Erlang, right? So Rabbitmq is written in Erlang. So this is actually Erlang now running in Kubernetes. And that's what's going on. And so let's open up a third tab up here at the top. Let's zoom in a little bit. And let's do kgetpo. And you can see here, Rabbitmq, we have 1 of 1 ready. It's in state running. And if we want to see the logs, we can see them over here. We'll throw in some black space here. And we'll come down here, and we can still do kget deploy and everything else and see what's all running in our default namespace. Okay, Kata's installed. Rabbitmq is installed according to whoever wrote the chart for Rabbitmq and put it in that repository. And that's what we're looking for here. And it says, be sure to wait until the deployment has completed before continuing. And I got in trouble a little bit earlier, which is why I did this sort of instinctively when I got here, just to make sure that we saw 1 of 1 ready right here. Because Rabbit does take some time to kind of get happy Erlang problems. Okay, so next we want to do a kubectl apply of what we call a consumer. So if you've ever used Rabbitmq before, you'll know that there's this concept of producers and consumers. So we're going to draw a picture, because that's what we do. And I know I'm going long on this episode, but whatever. It's my last episode at the Heptio office, and this is fun, so y'all get to deal with it. Okay. So here we have a message broker, and we're going to call this thing Rabbit. And Rabbit is fantastic. It's a fantastic message queue. It's probably my favorite message queue. And it has some really interesting guarantees in it. And that is that way. And I'm just drawing some pieces here. Okay. So what we have on this side is we have in number of producers. And then on this side, we have in number of consumers. So what would happen in this example, and just so you understand the terminology as we're going through it here, is a producer would create a message or create work in our message broker in this specific queue. And let's say this queue is called /hello. And let's say we have another queue that we're going to call /goodbye. So this producer might stick messages in hello, and this one might stick messages in goodbye. And the way that Rabbit works is a message comes in, and the first thing Rabbit does is it persists it to disk. And this is one of the huge things that's important to Rabbit, which means if our program breaks, so at some point, if our program broke, this person no longer has the message because they stuck it here. This person has not consumed the message yet, and our program just died and all that memory went to waste, so we lost that message forever. So one of the important things that Rabbit does is it persists it to disk until this comes along and reads the message and also goes back and acts and says, yes, I have the message, and then Rabbit unwrites it from disk, and that's how the Rabbit message queue works, so that even if your program breaks, you're always able to recover your messages back from disk, because Rabbit will not acknowledge this one until it's been written here. So we just get some really powerful guarantees. So as long as our producer respects Rabbit and our consumer respects Rabbit, we're allowed to put as much work into Rabbit as we want. And if if Rabbit breaks or goes down, we know we don't lose any work because it's been persisted to disk down here. And all a producer does is create messages or create work, and all a consumer does is read messages and read work. And that's how pretty much every message broker works. Or event-driven system works, and that's the Rabbitmq and why it's so exciting. Kafka works in very different ways. So anyway, that's Rabbit, and that's one of the reasons why Rabbit's my favorite. Okay, so that's my Rabbit rant. So let's go back to my screen or my face. Okay, so it says we want to deploy a consumer. So we go in here, let's change directory to go source github.com. Marcel says, kind of. I feel to be in the Java world now. Go source github.com, Kata, core, what is it? Sample, go, Rabbitmq. And then in here we have, what was it, deploy? Yeah, so let's cat out this consumer and see what's going on here. Deploy consumer.yaml. Okay, so this is what the instructions are telling us to deploy. So we have a deployment here. It's called the Rabbitmq consumer. And again, the consumer is the piece that's listening. It'll be reading from Rabbit. And this is probably already configured, to use our default username and password, Rabbitmq. So this is hard-coded to just basically be a consumer. And I picked on Jeff a little bit earlier, and he said it was okay if I pick on him now. Ideally, even though this is, well, it's a sample project, so it's kind of okay. But ideally, we would not want to be using a single person's container registry here, if at all possible. If we could get that into the official one, just to kind of keep things tidy, I would feel safer as an engineer who's running this. Serving does activation, deactivation only on HTTP. Kata does a bunch of it for event sources, Rabbitmq, Kafka queues, etc. Thank you, Jeff, for clarifying that. Okay, cool. So all of this is it's running this program here that it's called Jeff Holland Rabbitmq client. And I bet if we go here, we can see that, yes, there's this command here, and we have send and receive or produce and consume, producers and consumers. So this would be our producer and this would be our consumer. So I bet all this is doing is just a simple Go program that just talks to Rabbitmq. And of course, that's precisely what's going on here. Agreed, and good feedback. Thanks for letting me pick on you, Jeff. I appreciate it. And thanks again for helping me out earlier today. Okay, so Jeff wrote this really simple program, and all it does is it just demonstrates some work for us to use Kata. So thank you, Jeff, for doing this. So it's making our demo much better. Okay, so we're going to run our consumer. And you can see here we actually got a scaled object for it, and we have our deployment. So let's do our kubectl apply -f. Let's see what's in here. Deploy consumer.yaml. So we run this command, poof. So now you can see it created a deployment in our scaled object, which is good. So let's do kget scaled object. We have the Rabbitmq consumer. So this is what's actually running in Kubernetes here. Our Rabbitmq consumer, we have a deployment name. Here's our username and password. Hard-coded into our deployment here. I would like to see this in a secret, but again, it's a sample project. We're kind of more interested that it works, and we can demonstrate how Kata works and less about actually keeping this thing secure, since we're just doing a demo and we're not running this in production anywhere. Okay, so let's see what's going on here. kget pods, you can see we have that running. So we have our Rabbitmq running, but we don't see anything running for our consumer. Now think about this, right? So the way that this system is designed with Kata is a message comes into this piece of software that I have highlighted here, the Rabbitmq message broker itself, and then Kata will auto-scale pods necessary to do what we looked at here, to do this. So Kata will create a pod for this one. It'll create a pod for this one. It'll create a pod for this one. It will create all these pods as you go down, and you get more and more consumers. I know, I'm getting sloppy, right? And so anyway, don't pay attention there. But as we're creating more consumers to act the work that we're putting into Rabbit, we're going to need to create more pods along the way. So we don't have any work in Rabbit, so do we see any pods? We don't see any pods yet. So let's generate some work, and then we can watch pods auto-scale. Can this be scaled up from 0 instead of 1? Ashish, can you be a little more descriptive of what you're referring to? Are you talking about the Rabbitmq instance, or are you talking about the consumer? Arthi says yes, and yes. Okay, so I'm kind of confused what just happened, but it looks like everybody figured it out. Okay, so anyway, now we're going to do our deploy, our publisher job here. So let's go look at our publisher job and see what's going on here. Kubectl apply -f, deploy publisher. And let's cat this thing out. List cat deploy publisher job. Clear our screen again, and there we go. So it's a batch job. So a batch job just kind of like runs like a cron job. It just runs once. And it's going to pull this other image that I'm assuming is built from this other Go command here, and it's called Jeff Holland Rabbitmq client. And again, this thing, it's going to do a send to the Rabbitmq server. So all this is going to do is just send a bunch of messages. And I bet if we go and we look in Jeff's code here, we can see command, send.go. We can see that he's probably doing some exciting things here. So yeah, it takes in message count as one of the arguments. And I bet here in our build file, our Docker file, we can see which arguments we're defining, or maybe it's in our deployment. Let's see if it's in our batch job. Image pull policy always. Image, I don't see any arguments defined here. So somehow we're passing in, I think maybe this is it here. Yeah, 300. So these are the arguments. We're telling it to send. We're giving it the username and password, and we're telling it to create 300 messages. So we could actually edit this 300 and change it to like 1,000,000, and it would be pretty exciting, and it would probably break our cluster. Ashu says, I think you answered, there is no consumer running or 0 consumers are running. Expecting add more will be as messages come in. Yes, Ashish, you are 100% correct. So let's apply this, and let's watch our 300 messages go into Rabbit. So kubectl apply -f deploy publisher job .yaml. Okay, and this is where like things are going to get exciting. We're going to deploy this. We're going to do kgit po -watch, clear our screen. All right, this is cool. So Kata is automatically scaling containers to keep up with our job that we're creating in Rabbit. And if we come here, you can see here's Rabbitmq having a party. Here is Kata itself having a party. And you can actually watch these pods kind of come and go. And for good measure, let's open up a 4th tab, zoom in, and let's do a, let's see what our docs say. There's a command here that they say we can run. Get HPA. So this is exciting. This is going to get our horizontal pod autoscaler, and here you can see how many targets we have, our max pods, and how many replicas. So this is our, we can do a -watch here. And now, like, if I was like a systems admin, I would have all 4 of these pulled up like on my screen, and that would be like my command station, right? That's what I would be. I would be watching all these different components. And you can see here we're creating containers, still having a party in Rabbit, still having a party in Kata, and if we just come out of here, you can see we actually pulled the number of targets down because the number of messages in Rabbit are now shrinking. They're now getting smaller as these consumers act on them. So that's Kata. We created an event. We generated some synthetic work, and we watched the Kubernetes horizontal pod autoscaler scale up and down as we put messages into our system and as it needed to complete some work. So big takeaways here. I'm going to zoom out and do my thing here at the end. Okay, so big takeaways here. If you want to write a scalar, you can. And I'm assuming PRs are accepted. It's open source, right? If you want to write a scalar for whatever arbitrary event you want, it could be an event broker that you wrote in Bash for your company. I don't really think it matters. It's software. We can make it do anything we want. Minpod is 1. Ashish is thinking about something. And then you could build that into the code base here. Right now you would have to hard code it in, but it sounds like they're open to the idea of having some dynamically loaded configuration system, which Helm has one of these. There's a bunch of examples in Kubernetes. Arthi, if you want to see an example of like how to do some dynamic plugin-y stuff, I can show you some source code that I think you'll enjoy based on the code that I looked at. It looks like you think the same way as a lot of the other Gophers I work with. Jeff says HPA has a minimum of 1 today. Okay, so it looks like Jeff is changing this on the reg. And I could come through and change it and rebuild it and everything too if I wanted to, but I don't need to do that today. We've all seen me build containers before. And Jeff says, and yes, please help. We have community calls every week and are happy to accept contribution. Already people working on things like AWS SQS scalars. I think it would be really great to like build like a troll scalar, like check if GitHub's up, and if GitHub is not up, it like spins up all these consumers that like tweet or something like that. That would just be like a fun project to build to learn how KEDA works. So yeah, you could use KEDA for anything like that, but right now it is going to require a source code change, and that's fine. That's how we started in Kubernetes, and now we have CRDs. The first time we wanted to create a new object in Kubernetes, we went through and we added it to the standard library. Now we don't have that because we have CRDs, and those are dynamically loaded, but we have to start somewhere. So that's where we are today with KEDA. And you can see here, if I go back, you can see these pods have now since terminated. So our work has expired, those pods are no longer needed, and the HPA is scaling back down to 0. In fact, I bet if I do a kgit PO here, kgit PO, we're back down to 0. We have 1 pod running. Jeff says, spoiler alert, that scales after Game of Thrones ends in tweet spoilers. A spoiler scaler, that's a great idea, Jeff. So yeah, Jeff says we should have a Game of Thrones spoiler scaler. That's really hilarious. Okay, so anyway, build your scalar in. PR is accepted. Hook it up to the horizontal pod autoscaler in Kubernetes using one of the service objects. Did I say that right? Let's see what we got here. So I did kgit CRDs, or kgit, why can't I do kgit CRDs? Kgit CRs? I don't know. Anyway, creates that, glues that together with the horizontal pod autoscaler, and will scale our pods for us. Now remember, this doesn't scale infrastructure, this just scales your pods, but if you're doing any sort of burst processing, like maybe you have this like one batch job, or like I know Holden, she was on the call earlier, does a lot of work with Spark and has like famous for these like I'm gonna like run this like one Spark job, and it's this ephemeral thing that runs for a finite amount of time, and it just hammers our system. And does a bunch of like fancy Scala machine learning stuff that I don't understand. And you know, something like KEDA would be able to distribute that work a lot better, and we could automatically scale up and down as those jobs came into our work queues and not. So if you're doing big data processing, if you're building a data pipeline, something like KEDA might be appealing to you. And if this is something that you've been wanting for a while, you can now come in and join this community and start working with KEDA and our friends at Red Hat and Microsoft. So Arthi, your code is gorgeous. I love it. Jeff, thanks for all your help today. It's been great. I am going to get out of here. So let's do everybody's favorite part of the episode. Let's say our goodbyes. This is our last time in the TGI studio. I want to like take one of these like sound things home and like frame it on the wall or whatever. But yeah, this is kind of surreal. Last time in the TGI studio. Last time I'll be here at the Seattle office. I love this studio so much. This is where it all started. And we're going to get a new one soon, and it's going to be really exciting. But thanks, everyone, for joining. It's been great. This was a fun episode. I had a lot of fun. I'm sorry I went and did an hour and 40 minutes. I usually try to do an hour and 20. But we had a lot to talk about, and I kind of got derailed off on a tangent quite a bit. But yeah, thanks for joining. It was great to see everyone. Have a wonderful weekend. We all know what I'm going to be doing this weekend, so wish me luck. And I will see everyone next week, I think from home. Maybe from Joe's basement, maybe from my house. Unsure. Ashish says one more round of trivia. Okay, you want to do one more round of trivia? Let's do so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll do one more final round of trivia, and then we're going to pretty much be out of stickers. So I might be ordering some more stickers if I can find my own template. Okay, so Ashish, what do we want to do trivia on? Let's see here. Y'all can't see my screen, so I'm going to look up a good piece of trivia here. Okay, so what I want everyone to do is to open up the HackMD and scroll down to the very bottom of the HackMD. The link for the HackMD is here. So if you scroll down to the very, very bottom, there's going to be a section here called Trivia. And I'm going to paste a question in, and the first person to type in their answers, type in your answer like this. Kris Nova, no, or actually just do this. Do your name, Kris Nova, and I think the answer is blah, and then whatever your answer is. And just type it in on any one of these lines here. If you want to grab a line now, grab it now. There you go. We can do this. So the question here is going to be, let's do a good Kubernetes one. Okay, so I saw this one earlier on Twitter. So what Kubernetes release defines the official pronunciation of kubectl? There's a release number that's out there, and it's in the changelog, and we're going to look it up together. Which Kubernetes release defines the official pronunciation of kubectl? And here is a hint. Bam. There is the answer. And this is in Kubernetes. Scroll up, scroll up, scroll up, scroll up. And we'll just go back. Version 1.9.11. So we're looking for version 1.9.11. Let's see who gets it. Nobody's gotten it yet. The answer's out there. Here, let's see if we can do this. Really troll some folks here. Okay, nobody got this one. Let's do a different one. Well, who's AA? There we go. AA got it. So who's A? Is that Ashish? I'm assuming that's Ashish. Let's look in chat. Madness, there is an official pronunciation? Yeah, there's an official pronunciation, but that's not official. It's just in the changelog. That doesn't mean anything. Nobody reads the changelog. I read the changelog, but I don't think anybody else does. Okay, so let's go back to our chat and let's see who won. So who is AA? Who is AA? That's who won. Ashish. Okay, cool. You know what to do. Send me your information and I'll get this stuff in the mail as soon as possible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, come find me at KubeCon. We're going to have a lot more stickers and fun. Joe and I are going to do TGI. We're going to miss the Seattle studio, but we're getting a new awesome studio. And Joe and I and Duffy and everyone else will be doing TGI from home for a while. It's been a great past 2 years here at the Seattle Heptio office. We wouldn't be where we were today if it wasn't for you and everybody out there. So thank you on behalf of Heptio, on behalf of VMware. We couldn't do it without you. Click that subscribe button right here on YouTube. Support us, and we will see you all next week. Have a great weekend, everyone. Bye.